Well, hello everyone and welcome to the first in a series of webinars that BHR Group is running on the theme of engineering innovation. This is a topic that is close to our hearts, as we know that to position yourself in the market, increase market share and differentiate yourself from the competition, that it's vitally important that you continuously improve your products or processes. Innovation done correctly is one way that you can do this. However, it is also something that if you get wrong can be very costly. We at BHR have been supporting industry and in particular UK industry on this for many years. So I hope that from what you hear today, we have the experience in this area, that we understand the challenges that you face and that we're here to help you meet them. In this series, we will be dipping into some of the learnings that we have picked up over the years while helping customers conceive and develop what they expect will be a successful engineering development process. As you can see from today's title, we're looking at the beginning of this process with your amazing idea. So once again, thank you for joining us. I hope that you enjoy the webinar, and having invested your time with us today, I hope that you also get some real value that you can implement in your business. But before that, let's agree what we understand by these two words, engineering innovation, as this will help us set the context for this and the other webinars in the series. Excuse me. Firstly, we are focusing on the engineering aspects of innovation and not so much the wider aspects such as a market opportunity, competitive advantage, creating the right culture and so forth. We will of course touch on some of these as they are vitally important, but they are well covered elsewhere. Next, look at the word innovation, which can mean different things to different people. And as you can see from the quote on the screen, it can get quite complicated. So within the confines of these webinars, we're taking the liberty of simplifying innovation to a step that adds or creates value to a product or process. The key words here are that it adds or creates value. And by value, we're not really limiting ourselves directly to financial benefit. It could equally be around strengthening your reputation, accruing more IP, and so on. Moving on to today's agenda, we're going to be here for about 30 minutes, starting with me, setting the context, and then sharing our experiences. This will include me presenting a 3-step guide to help you create, shape, or challenge your amazing idea so that you can turn it into a winning business proposition. These steps are not exhaustive, but a snapshot of the advice and learnings that we often need to use ourselves. That will be followed by my colleague Mark presenting a case study, talking in particular about the experiences and learnings that we and our customers have gained. But most importantly, for you and us to get the most out of today, we'd really like to hear from you during either the presentations by using the chat function on the right, or in the Q&A sessions at the end. Today is all about what you take away, so please take advantage of these facilities during our time together. So before we start, a few reminders. Please use the chat and stick around for the Q&A. Please give us your feedback, as this helps us judge the content and delivery of the webinar and how useful it has been to you. And today is all about the actions that you take. So while a video of the webinar will be available, please use this time to make some notes as we go along. A few introductions. I'm Jerry McNulty, that's me on the left, and I am a business development manager responsible for developing relationships with key customers across the nuclear, oil and gas and defence sectors. I'm your host today, and I'll be presenting, as I said, our 3-step guide. I'm joined by a couple of colleagues. Firstly, Mark Fairhurst, shown in the middle, who's one of our senior consultants and a specialist in high pressure engineering and fluid power systems. Mark has been involved in many product development programs, providing valuable engineering consultancy advice, tempered with pragmatism, that really have helped our customers turn concepts into viable engineering solutions, but more importantly, compelling business advantages. Mark will present a case study from which we hope you will take away some valuable insights. In the background, keeping us under control and managing the chats, is Kate Goldberg, our marketing manager. So thank you both for working with me on this webinar today. To help you understand where we fit into the engineering innovation process and why we are able to talk on this topic from a position of some authority, I think it's helpful for you to hear a little more about BHR Group. For those of you who haven't heard about us, we're a specialist engineering consultancy based near Milton Keynes, which is half-hour train journey north of London, here in the UK. Our experience is in the application of fluids engineering to solve problems for industry, which we've been doing since the 1940s. So we've been around a good time. Now, fluid engineering crosses most, if not all, engineering disciplines, and so we're in a really privileged position of working for many different industrial sectors, each with their own needs and challenges. This gives us a great opportunity to understand various engineering and business demands and to adapt our know-how in a safe and effective way to meet them across a whole range of different engineering sectors. As experts, we see that the greatest benefit that we can offer you is to understand, quantify, and mitigate engineering risk in your business. And we do this in a number of ways. First and foremost, we provide expert-led advice and insight, which helps you see the possible ways forward in your engineering development, each with different paths, opportunities, risks, and rewards. This is supported by what are the usual tools and techniques that you might expect from an engineering consultancy, such as design optioneering, predictive modelling, simulation, calculation methods, and all kinds of other kinds of engineering studies. However, unlike many consultancies, our expertise is supported by industrially funded and collaborative R&D services. And this, together with our specialist test facilities, allows us to regenerate our know-how. Of course, this also puts us in a great place while working alongside customers to build and scale up physical products and processes in a laboratory-controlled and therefore risk-controlled environment. We found that this helps us strengthen these relationships, and as we become trusted partners, we can support customers in areas such as testing and pre-production prototypes or run demonstrators under simulated operating conditions. So we can really provide end-to-end support from concept development through to demonstration. As you can imagine, this puts BHR in a great position to gain experience and learnings directly with customers that we share both on future direct customer engagements and more widely through events such as this. Well, I hope that this gives you some appreciation of what we do and gives you confidence that we know what we're talking about. Now that I've set the scene, let's look at some of the things that we have learned that we hope will help you turn that good idea into a winning idea. As I mentioned earlier, we are drawing on experiences that work for us in different industrial sectors and for quite different types of engineering application. What we've found is that there are processes that can help you on this innovation journey, but it's not a one-size-fits-all kinds of thing. And because of this, you need to constantly revisit your innovation and business goals, and also know when and where to look for help. So today we're going to cover a range of topics, but please understand that we're not experts across all of them. But what I can say is that our experiences is that if you follow some of our advice, it will help you maximize the prospects of getting your concept onto a solid engineering development path. So now let's jump in and look at some of the lessons that we have learned. Okay, so you've got a big idea. The first thing you must decide is what your first step should be. This is not as simple as it sounds, and in fact it can be tricky at business as it requires you to make judgments on things that you might not quite have a full picture of. For example, even limiting ourselves to the engineering challenge, you will need to consider what other skills you need, what skill you might be testing at, how much these tests will cost, who's got this test capability, and so on. This beginning is particularly difficult for startups and smaller businesses when compared to established players, they are more likely to have an incomplete and more fluid picture of their business goals and the market opportunity, and so on. I should add that they are also likely to be more personally invested than in larger organisations, and this presents a host of other challenges. So before you start, stop. Most innovations do not make it to market, and so in an investment that comes with a slim chance of commercial success, but great rewards should you succeed. You need to ask yourself a few more questions, such as, has this been done before? Because it probably has. So you really must do your background research, as there are likely to be lots of other ideas, many of which are viable commercial solutions already out there. You might think that this is bad news for you, but that might not be the case, as I will come on to. So the first thing you need to do is be sure that your idea is new, not only to you, but to others. For instance, your co-workers, your wider business network, and so on. And remember that it's not only has it got to be new, but as I mentioned earlier, it has also got to create or add value. That's the whole point of innovation. Having done this, find out what is already in the public domain or already protected, and so you really should do a patent search. You might think that this is an obvious step as it establishes potential blockers to your idea. What is less obvious is that it is also a rich source of valuable information that someone else has already spent time and energy on, and which you can learn from. So be sure to understand the wider intellectual property landscape, and that intellectual property is not just patents. It does worry me the number of times that entrepreneurs who approach us, especially in engineering companies, don't do their research and so don't get a fuller understanding of the IP and in particular the patent landscape. It equally worries me that when we're approached by someone who already has spent money taking out a patent before doing some initial R&D. So we advise that you have a professional patent search carried out. The most obvious reason for doing this is to find out if your idea is an original idea. But of course, the findings of this could kill your idea, in which case you've saved yourself further unnecessary investment cost. But on the other hand, if a patent has lapsed or has expired, it's a stepping stone to other ways forward for you that I will come on to. And finally, innovate only if necessary. I can't emphasize this enough. Do not invent, create, adapt, or innovate unless you absolutely have to. Because as I've said, the answers might already be out there, and so there might be costs that you can otherwise avoid or minimize and ultimately get your idea or some part of that idea to market quicker. A quick win could come through your patent search, as it gives you access to some of the outlying workings behind other people's ideas, and this could be useful to you. This could be good news, as you can use the findings to judge the advantages of your approach to that stated in other patents. And there's also more that you can do. If you're really bold, why not try to contact those patent holders and have a conversation about how working together could help accelerate the development of your idea. Which takes us nicely to step number 2, which is to use everything of value that you have found out. If you decide to patent, you will need to think about when you want to apply for one. The reason I mention this is because your idea might change during the development process, and if you have already patented, this can lead to other complications if you've made the claim too limited. So don't rush into this, but be clear on when you expect to be in a position to patent, and perhaps as importantly, the steps that you need to take to protect your IP in the meantime. You also need to plan your route to market. I expect that by this stage in the process, You will have a more complete understanding of the IP landscape, and so you will be in a more informed position to revisit or map out your business and product development plans. Again, the degree to which you can do this will be influenced by the maturity and size of both your business and the innovation. We have found, for small companies in particular, that a good starting point is a simple dashboard, something like this, that will help you clarify your current understanding. This can help because even small organisations can forget to present their current understanding or assumptions to key internal and external stakeholders. As I said earlier, their business plans can change and everyone needs to quickly adapt or respond in the light of these changes. One element that can significantly affect your plans is funding that you have in place or that you're seeking to put in place. So plan how you're going to access funding. One of the main reasons we've seen ideas fail over the years is because they run out of funds before they are investment ready. So if you're trying to develop a product on a limited budget, your key development goal is to get the concept to a point where you can get further funding. And of course, this should also be explicitly stated as a key resource requirement in your route to market plan that we've just shown a moment ago. The final step you need to take is to define the requirements. Now, in engineering, we all get the importance of stating the functional requirements. We'll dig a bit deeper into this in a future webinar, but for now, let's accept that these can have a major influence on what your innovation will look like in some future application environment. We also need to recognise that as the initial idea moves to design and then manufacture, that when the product or service has to do and what it is likely to be doing is likely to change. So these requirements need to be stated simply and unambiguously, and then revisited and reviewed throughout the development process. So really think about and understand the application. Understanding enough about the application environment can be really tough for an OEM, especially for smaller companies. I expect that we all know that one of the best ways to avoid or minimise missing key information that affects the functional requirements is to get an end user or someone up the supply chain, further up the supply chain on board. Now, you might be fortunate and get someone who has a vision of how your innovation will benefit them, and better still be in a position to influence how their company will support your innovation down the line with things like site tests, an understanding of the reliability and maintenance requirements and so on. Yet even here, you need to be aware that they are unlikely to have a complete picture of the functional and operating environment and their associated constraints. So you need to ask them questions that will help fill these gaps. But of course, asking a question is not the same as asking a right question, and it is often the questions that aren't ours that will prove to be important further down the development path. We find that this is a common challenge and needs everyone involved to be engaged, open, and honest with each other. Now, this is something that you're likely to achieve more quickly with your internal team, but which is likely to take longer when you've got external stakeholders, where you need to build credibility, mutual respect, and eventually trust so that they and you can open up. Another thing to consider is the bias of the questions. At BHR, we are mainly professional engineers with mechanical, chemical, aerospace, and civils engineering backgrounds. Now, as engineers, we are sometimes guilty of pouncing on the first answer that fits with the requirements. And so you need to have processes that challenge your questions and answers so as to minimize this thing called selection bias. Another way to counter this is to include non-engineering specialists in your team. Some of the most successful developments have arisen when we have involved, dare I say, scientists or non-specialists in our teams. And I guess this is because they have a different way of looking at and working through the challenge. And one of the reasons for asking the right questions is to really understand your limitations. For example, Here are the results of some questions we asked ourselves early on in the development of the Hydract valve actuator case study that Mark will present in a moment. We arrived at these results through a Stagegate process, which was as far as possible based on data and not opinion. As you can see, we didn't score highly in any, but we did demonstrate a well-rounded set of capabilities. So while initially we were quite shocked by about how much we had to learn, knowing what we did spurred us on and it gave us focus. So just to reiterate, stop and consider what you know and what knowledge is out there. Use these learnings, define the requirements. In the next webinar, I'm going to dig a little bit deeper into working with limitations and constraints, but that's it for now, our 3-step guide to help you get your concept onto a solid development path. And with that, I will hand over to Mark via Kate, and he's going to present the case study.
So we should be over with Mark now to begin the case study.
Thank you, Kate. As Jerry said, I'm going to talk about Hydract as an example of turning a good idea into a winning idea. So Hydract stands for hydraulic actuator, and the idea was to develop a water hydraulic actuator that could match or better the performance of pneumatic actuators. Pneumatic actuators are the industrial standard and have been used for the past 40 years in the sanitary valve industry, specifically the brewery, dairy and pharmaceutical industry. Kate, could you move the slide forward, please? Thank you. The original idea was the brainchild of the owner of KM Rusfree, a small Danish company that supplied deep-drawn stainless steel components for the food and beverage sector. He patented the application of a water hydraulic actuator for valves in that sector, as he recognized that compressed air actuators were very wasteful in terms of the energy they required to operate. The idea had been in the inventor's mind for several years, but grew in importance as he looked to diversify the business when sales of his stainless steel components were suffering due to cheaper imports from the Far East. Coincidentally, Carlsberg faced a similar issue in Denmark, as they envisaged having to import beer from their breweries in Russia if they did not reduce production costs, specifically at their flagship brewery in Fredericia. Reducing their energy bill was one approach worth investigating, but more important was a change in beer production technique to a process called late brew. They saw consumer drinking habits changing to seasonal beers and needed to respond with a more flexible approach to production. They needed to build up stocks of beer and then blend them in a matter of weeks to fulfill the sale orders. This required a more agile production process that would require retrofitting smart valves throughout the brewery. And so the Hydract actuator concept was born, with the goal of fitting them to existing mix-proof valves, but without a major overhaul of the brewery. Next slide, please. Thank you. A typical brewery has 3,000 to 4,000 mix-proof type valves that prevent contamination of the product with the cleaning fluids necessary in production. The valve market is dominated by several large manufacturers supplying these pneumatically operated valves that are energy hungry. And this is due to the inefficiencies of using a compressible fluid and also, of course, the air leaks that are so common in such installations. Using incompressible water instead of air would significantly reduce the power consumption of the actuators, while also offering the higher degree of control typically afforded by oil hydraulic systems. So this offered the tantalizing prospect of an energy-efficient valve that was multifunctional, namely, it could be used for both isolation and control. So we had an idea and a potential market with people at both ends driven to see it work. These were the initial product champions, but to succeed, everyone in the project had to share their enthusiasm. The inventor needed both technical help to develop the product and financial support. Carlsberg were happy to supply the site to test the prototypes, while the funding came from investors, loans, and government grants. Next slide, please. The project was thus formulated, and the partners set out to identify the challenges of developing a water hydraulic actuator initially aimed at the brewery sector. And this is where BHR came in. We used our experience in building collaborations to develop the innovation partnership and then manage the development program. As experts in fluid engineering, and more specifically, fluid power and high pressure water systems, we also led the engineering developments. The product was clearly going to have to meet stringent standards relating to the application in the food and beverage industry, but was also bound by regulations for pressurized systems and manufacturing within the EU. The challenges came from a number of factors: a known history of poor sealing performance with high pressure water systems, the problems of converting essentially industrial hydraulics into a sterile system for food manufacture, having to develop a wireless communication network with Internet of Things connectivity, and only basic levels of control from existing water hydraulic valves that were currently on the market. Next slide, please. It is fair to say that we were not experts in brewing or the design of mix-proof valves at the start of the project, so we expected to go up a very steep learning curve. At the beginning, you have to gather as much information as possible to benchmark the product to assist in the writing of a functional specification. I cannot stress enough the importance of preparing this initial specification. It gets everyone on the same page, all the partners can contribute to it and have to buy into it. Some elements will be hard, such as the standards related to the safety of pressure systems, and of course food and beverage cleanliness, for example. Some aspects may be classified as softer, such as compact design or easily maintainable, and these will need to be firmed up at a later stage. It can also be useful to put weighting factors on the specification so that you can see the wood for the trees. We did this on the choice of seal materials, and it certainly helped to narrow the field. Breaking the challenge down into packages that can be worked on independently helped. The building blocks can then be developed and tested quicker and more cost-effective individually before integration into the complete system. Communication between the collaboration partners and other stakeholders and keeping an eye on the specification are all important, or the pieces will not fit together. Next slide, please, Kate. The key learning here is to meet the key influencers from innovators to end users and talk face to face. So building a good relationship with the brewmaster at the brewery and frequently exchanging ideas kept the product development relevant. This not only prevented us going too far in the wrong direction, but also identified other value-added benefits for the new product for the end user. Talking to the production engineers and maintenance staff indicated how the new product could be made easier to maintain and designed to prevent many of the in-service issues seen in the historic pneumatic designs. Even relatively simple changes could make a big impact. Adding a load sensor transducer to the actuator prevented valve seal damage and also removed the need for frequent valve adjustment in what is usually difficult to reach locations. Next slide, please. For BHR, the pressure was on to design the hydraulic system, including the actuator. Now, I do not believe in reinventing the wheel, so I used existing water hydraulic products where they had a proven track record and made sure that they could be sterilized to food industry standards. Luckily, I had in-house expertise at BHR to help with water sterilization, and so was able to adapt the hardware and proved it was up to the required standard by doing laboratory trials using accepted food and beverage cleanliness monitoring techniques. We made a lot of early prototype parts in-house, and those that were made outside frequently needed to be modified to get them to work. So having the flexibility to do this certainly speeded up the development stages. As I said earlier, we ran into a problem when it came to the control valves for the actuator. The development of a control valve thus became the key to the success of the product and would bring many other benefits from the product with increased controllability. To design the valve, we looked at where others had failed as much as where there had been successes. The idea was to try things quickly as a screening process before going too far down the road so you could not turn back. Cavitation, lack of lubrication, and low viscosity are all real challenges for water hydraulics, so we needed novel solutions so as not to fall into the usual pitfalls. The use of modern engineering plastics, close attention to surface finish, and having a design suitable for manufacture were all important to a successful outcome. One thing that is essential is that you understand the science behind why things work. If you rely on just trial and error, you will probably go bankrupt before you succeed. The other thing that we found is that the devil is really in the detail. If your prototypes worked because of a high level of detail in surface finish or the removal of sharp edges, for instance at seal leadings, etc., then these need to be carried through to production and they need to be clearly specified on the drawings. As Jerry mentioned, you need to be a committed team to deliver innovation. BHR was involved in Hydrac development for 6 years, and while no longer involved, felt a real pride when an initial public offering for the Hydrac business was launched into NASDAQ in April of this year. Next slide, please. So in summary, we adapted a lot of what we knew from the fluid power industry, high pressure water jetting and sealing technology. We had to listen a lot to others from the brewery industry about their needs and pick up best practices along the way. We made mistakes, but we learned from them. Having a clear specification helps in communication with others, helps set targets, and keeps you on track. I will now hand back to Kate so that we can go through the questions and answers section. Next slide, please, Kate.